kitchen.
Hello everyone, a very good evening. Welcome all of you to this platform, Om Institute, and yes, here we are again for another GATE and ESE concept booster session. And we have from Monday we've taken an important topic. Important maybe for maths also, important for aptitude also, important in general for your engineering also, for some technical areas also. Yes, that is the probability, and especially an area where many students lag behind, they are confused, they fear about this topic, and that is why we are here to have our mastery in this topic.
Monday we've taken an important topic, important maybe for maths also, important for aptitude also, important in general for your engineering also, for some technical areas also. Yes, that is the probability, and especially.
Yes guys, I just let me check, looks like some together. Just a second. Okay, yeah guys, let's keep checking. Hello, mic testing 1 2 3. Hello. Let me just reconfirm it again. Why is that suddenly coming up? Okay, yeah guys, let's keep checking. Hello, mic testing 1 2 3. Hello. Just reconfirm it again. Why is that suddenly coming up? Okay. Parallelly, now you can also confirm me. Let me again check it out. I think still there is some audio issue. Just a moment. Still there is some audio issue. Let me just check it for a moment again. Just a second. Okay, so do let me check it out once again. How is that responding? Sorry guys, just maybe a minute or two, and let me check whether it is working fine. Okay, so do let me check it out once again. How is that responding? Sorry guys, just maybe a minute or two, and let me check whether it is working fine. Okay. I think looks okay now. Yes guys, so yes guys, let's get started. I think the audio issue now has been eliminated. Okay, so let's get moving ahead. So as I was telling you, we are here to do mastery in probability, because this is one important topic for your entire engineering, for maths, for aptitude, for technical, for some of the technical areas as well. Okay, now in the previous part, that is part number 1, I'll brief you about those things, what is the type of logic we have discussed in the part number 1. Okay, in case of any sound issue in between, you can let me know. In case the sound again comes up. Good evening, Dinesh. So yes guys, this is a brief intro about me. Hope you already know about this. Okay, so before I tell you what we did in the last class, let me again keep you reminding that the GENCO examination is going to be conducted on 14th of July. And yes, the Om Institute brings to you the free online test series for this GENCO examination. Okay, there will be 2 full mock tests conducted June 23rd and July 7th, and all these tests will be active at 1 p.m. It is free online test series, so do take the advantage. Already lots of students have registered, so in case you need to register, just scan here, and it's a free of course registration. Even you can appear in the test as free of cost. Just open the QR scanner of your mobile phone and you can register here directly. Okay, so this is what part number 1, which we completed on Monday. Okay, there our focus was, because probability, getting mastery, getting command in probability is all about seeing all its variety of question. Because ultimately every question is linked by one formula, favorable by total. So it is not about formula. Probability is not about formula, it is about logic, it is about range of questions. How many questions you solve, that much master you will become, and how you are able to read those questions, what is the logic behind that questions. Okay, so it's not formula based, it's purely logic based topic. Okay, and the first focus was, Venn diagram and counting based question. Now today, part number 2, our focus will be questions based on dice, cards, and some more miscellaneous questions, and then later on we move towards conditional probability based theorem and etc. topics, right? Okay, so let's get moving here. Okay, let's get started with dice. A very frequently asked question is with respect to the dice. Okay, now what are those questions? Let's have a look into it. The dice, the cards, and miscellaneous. A single die is thrown twice. What is the probability that? What is the probability that? The product is 6. Okay, you get a doublet, and the sum of the outcomes is at least 10. 3 different cases I want to discuss here. Okay, the 3 different cases I want to discuss here. Yes. 6. Okay. Yeah. Now the sound issue is not there. Okay. Yeah. So what are the three different cases that I'm discussing? Number 1 is product. Okay. You get a doublet, and number 3 is the sum. The very important one being the sum. Okay. The lot of questions you see in the competitive exam regarding to the sum of the outcomes of 2 dice. Okay. A single die is thrown twice. Okay. Now what is the sample space here, dear? Okay. For a dice being tossed twice. Okay, sample space, list of all possible outcomes. We also call it as universal set, and that is equal to how much? Okay, so if the first dice results as 1, what about the second? Second may be 1, maybe 2, maybe 3, anything. Okay, there can be any of the possible outcomes out of 1 to 6 in the second dice. Similarly, the first dice may be 2, but still, what about the second dice? It can take any value from 1, 2, 3, etc. up to 6. Okay, similarly, there will be the combination 3, 1 to 3, 6, and eventually the first dice can also take the value 6. Okay, and then second one again 1 to 6 cases, 6, 1, 6, 2, up to 6, 6. So how many of these cases? Okay, these are, okay, 6 in every row. Okay, and there are total 6 entries, 6 rows. So total 6 cross 6, that is 36 outcomes. Always you should remember, okay, this is the size of sample space, 36 outcomes, basically 6 square. Okay, if the if the die is thrown n times, okay, if the die is thrown, suppose n times, what is the size of sample space? Okay, size of any set, also known as the number of elements. So here I call number of elements in omega, and that is equal to 6 square. In general, if the die is thrown n times, the number of elements is given by 6 power n. The number of elements will be given by 6 power n. Okay, now what is the probability that product is 6, you get a doublet, and the sum of the outcomes is at least 12. Okay, so let's start with the product. Now product being equal to 6. Okay, first question. Okay, you need, okay, the product of the outcomes is 6. How the product can be 6? See, if the first dice is 1, second can be 6. If the first is 2, second can be 3. If the first is 3, second can be 2. If the first is 4, nothing. Okay, nothing, because 6 is not divisible by 4. If the first is 5, then also nothing. If the first is 6, second can be 1. Okay, so there are only 4 possible outcomes. Okay, that can give the product equal to 6. So what is the probability? Okay, favorable. How many favorable outcomes? 1, 2, 3. These are not to be counted. Okay, total 4 favorable outcomes. Favorable by total. How many total outcomes? 36. So the first answer is 1 by 9. Very simple one. Okay, second one. Okay, second one, you get a doublet. Okay, second case is the question that you get a doublet. Okay, so let us talk about the doublet now. Okay, so doublet means what? Doublet means the condition when you get the same outcome on both the dice. Okay, doublet is the condition, okay, when you get the same outcome on both the dice. Same outcome on both the dice. Okay, so what is the possibility? It may be 1, 1, same matlab 1, 1 also. So how many numbers are there? 6. So there can be 6 doublets, 2, 2. Okay, then there can be 3, 3, etc. up to the 6, 6. So again, what is the probability there? Okay, how many favorable outcomes? 6 possible doublets, and out of the sample space size, which is 36. So here it is 6 upon 36, and hence 1 by 6. Here the answer is known as 1 by 6. Okay, here the probability or the answer is known as 1 by 6. Right, everybody? Okay, let's move ahead to the next. Okay, let us move ahead to the next. Now third, okay, more important one, the sum of the outcomes is at least 10. The sum of the outcomes is at least 10. Okay, see, let's understand this, sum equal to 10. See, sum equal to 10 can be solved easily. Okay, what is the probability that sum is not 10, at least 10? At least 10. Okay, now, at least 10 means sum can be 10, 11, 12. The maximum possible value of sum is 12, of course. Okay, so if I start with sum equal to 10, okay, what are the outcomes? Okay, 4, 6. Okay, because if you take 3 on any one dice, so 3 plus maximum 6, 9. You cannot get a sum of 10. Okay, so that is why I start with 4, 6. Then next can be 5, 5, and then it can be 6, 4. Okay, if you consider the sum equal to 11, okay, so you cannot even take 4 because 4 plus maximum 6, that is 10. So you have to start with 5, 6, and then other way around 6, 5, and the maximum possible sum 12 is only under one condition, when you get the doublet 6, 6. When you get the doublet of 6. Clear? So that is 6, 6. So in total, how many outcomes are there? 6, 3, 2, 1. Okay, and hence probability here will be 6 divided by 36. Okay, and here 1 by 6 is the answer. 1 by 6 is the answer. Okay. When you get a doublet of 6. Now when I am telling you the sum greater than equal to 10 is the sum greater than equal to 10 is a or not greater than equal to 10, any question based on sum of the results of the dice is important. Okay, especially with respect to 2 dice. So let us summarize it. Okay, what is the range of sum that you can get? What is the range of sum that you can get? The minimum sum is 1, 1, 1 plus 1, 2. The minimum possible sum is 2. Okay, so 2, 3, 4, 5, etc. up to the 12. Okay, up to the 12. This is the list of the values of the sum that can be obtained. Minimum 2, 1, 1, and maximum is 12 with the 6, 6. Okay, so that is the range of sum. That is the range of sum. Okay, now how many cases will be there for sum equal to 2? Only one case is 1, 1. But when I take sum equal to 3, there can be the cases 1, 2, 2, 1. Okay, when I take the sum equal to 4, okay, so there can be 1, 3. Okay, there can be 2 also, 2, 2, and there can be 3, 1. So one by one number of cases will initially increase. When you talk about sum equal to 5, it will be 1, 4. Okay, or how much? You can take 2 also, so with 2, 3. Similarly, 3, then 2. Okay, if you take 4, then 1. Okay, if you want to consider a case of sum equal to 6, okay, so it can be 1, 5. Number of cases will further increase. Okay, then 2, 4. You can take 3, 3. You can take 4, 2. And next you can take 5, 1. Okay, and similarly, if you need to take sum equal to 7, it will be 1, 6. It will be 2, 5. It will be 3, 4. Okay, it will be 4, 3. All 6 cases will come up here. Okay, it will be 5, 2, and it will be 6, 1. Okay, now when you take dear sum equal to 8, now see, when I want to talk about sum equal to 8, okay, when I want to talk about sum equal to 8, you cannot take 1 on any one dice because 1 plus 6 maximum 7, you cannot get 8. Okay, so that is why here you have to start with 2, 2, 6, then with 3, 5, with 4, 4, with 5, it will be 3. Okay, and when 6, it is going to be 2. With 6, it is going to be 2. This is how it is going to be. Okay, similarly for sum equal to 9, you cannot even take 2. You have to start with 3. 3 plus 6, that is, okay, the minimum possibility to get 9. Okay, then 4, 5, then 5, 4. So what is the pattern now you are observing? 6, 3. Now it has started decreasing. Number of cases started decreasing. Then sum equal to 10. Okay, as I already solved. Okay, 10, 11, 12 we already solved. Okay, but just I want to make a pattern here. So 4, 6, 5, 5 and 6, 4. And sum equal to 11. Okay, again we got only 2 cases, 5, 6 and 6, 5. Number of cases started decreasing. And last, sum equal to 10. Again we have only one case, that is 6, 6. Okay, so initially we have one case, then we have 2 cases, then we have 3 cases, 4 possibilities, 5 possibilities, 6. Then again it starts decreasing. 5 possibilities, 4 possibilities, 3 possibilities, 2 possibilities, and a single possibility. This is what is the pattern we have obtained. So initial. Okay, so it increases 1, 2, 3, 4, 5, 6. Okay, then 5, 4, 3, 2. Now, how do we formulate this? How do we formulate this? Okay, so number of cases, dear. Let me write it here separately rather. Okay, number of cases for the sum to be equal to R. Number of cases for the sum equal to R. Suppose I say sum equal to R. It will be R minus 1. Okay, this pattern will be there for any value of R that is less than equal to 7. See, up to the sum equal to 7. Okay, for sum 2, 1 case, 1 less than 2. Okay, for sum equal to 3, 2 cases, 3 minus 1. For sum equal to 4, 4 minus 1. Similarly, till sum equal to 7, 7 minus 1, 6 cases. Okay, but then the pattern again started decreasing. For sum equal to 8, 5 cases. For 9, it is 4 cases. How do we write this? For any value of sum greater than 7, the number of cases will be 13 minus R. It will be good if you remember this pattern because the questions on sum, okay, a dice is thrown 2 times and the questions on sum are important. You can solve using this pattern. Okay. So suppose a single die is thrown twice. Okay, again, let's take a quicker question. A single die is thrown twice. What is the probability that sum of the outcomes is a prime number? Sum of the outcomes is a prime number. Okay, so sum of the outcomes is a prime number means what is the value of the sum? Okay, so the sum can be 2 to 12, out of which the prime numbers are 2. 2 is the only even prime number. Then 3 is the prime number. Then 5, then 7, and then 11. And then 11. How many cases for these? How many cases are seen for this? For 2 there will be 1 case. For 3 there will be 2 cases. For 5 there will be 4 cases. For 7 there will be 6 cases. But for 11, as I told you, for any sum greater than 7, the formula is 13 minus R. Okay, so here you will have 13 minus 11 equal to 2 cases. Okay, up to this I followed the formula R minus 1. And this is 13 minus R formula. Okay, so total number of cases. Okay, total number of favorable cases to get the prime number, so you can get it in 1 or 2 or 4 or 6 or 2, these many ways. Total, a single die thrown 2 times, the size of sample space we already know, as we have seen in the last question, 36. Okay, so this becomes how much? 7 and 15 is divided by 36, correct? Yeah, 15 by 36, or if I cancel with 3, it is 5 divided by 12. This is known as the 5 divided by 12. This is how it is.
So this becomes how much? 7 and 8.
This is the 5 by 12. Okay. Chalo. The sum of the 2 dice is important one, so we have dealt with it separately. Okay. Okay. Now next variety. Let's move ahead to the next variety. Suppose a fair 6-sided dice is rolled once. If the value on the dice is 1, 2, 3, then the die is rolled second time. Okay, so here I am first throwing a die only once. But if the outcome is 1, 2, 3, then I will roll it for the second time. Okay, what is the probability that sum total of the values that turn up is at least 6? Sum total of the values that turn up is at least 6. So second time is not sure. Okay, it's not sure. Yes, offline classes are going in Hyderabad. Aki, even I am taking and the entire team of home is taking. The offline classes are there in Hyderabad. What is the probability that sum total of the values that turn up is at least 6? Okay, now it is rolled once. Initially it is rolled once. Okay, so let us talk about toss number 1 separately. Okay, now what are the possible outcomes on toss number 1? 1, 2, 3, 4, 5, 6. Anything can happen on toss number 1. Okay, but if the value is 1, 2, 3, then it is rolled for the second time. Okay, then it is rolled for the second time. Toss 2. Okay, and what you want? You want the sum total of the values. You want the sum total of the values that turn up is at least 6. Okay, so I will write down the favorable outcomes of the toss 2. I will only write down the favorable cases. So whenever the toss 1 is 1, 2, 3, the second time the die is tossed. Okay. Now you want the sum is at least 6. So what should come up here? 5 or 6. See, toss 2 can have any possible outcomes. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. But I want the sum at least greater than equal to 6. What is my favorable case? Sum greater than equal to 6. Sum is at least 6. So 1 plus 5 is 6. 1 plus 6 is 7. Okay. If the first toss is 2, then you can take even 4 here. 2 plus 4, 6. And then 2 plus 5, 2 plus 6. All of them satisfy sum greater than equal to 6. If the first is 3, second can also be 3, then 4, then 5 and 6. If the toss one is 1, 2, 3, then only the die is rolled for the second time. But if the toss one is 4, 5, 6, 4, 5, 6, you cannot toss it again. Okay, you cannot toss it again. So there is no favorable case here. Okay. But still, if you don't toss it, okay, but the toss one is 6, still the sum is 6. Na? Okay, here, there is nothing on the second toss. Okay, there is no second toss, but still, okay, here, you see sum greater than equal to 6. And even in this last case, you see sum equal to 6. Okay, equal to or greater than 6 is allowed. Okay, although the toss one only is 6, so I don't do the second toss. I don't repeat the second toss because second toss is only done if the value on the first dice is 1, 2, 3. But still, the toss one is 6. So what do you see? The sum total of the values that turn up. So what turns up? This single itself is alone. Na? The single itself is alone, so that the sum is 6. Okay, so this is okay. Okay, this is also our favorable case. Okay, so now what is the probability? What is the probability? Okay, so I will write down the answer. Please see the pattern. See, I will write in this way. What is the probability of getting, okay, 1 on the one? 1 by 6. Okay, or I will write down these numbers individually. Okay, to explain you more better. Okay, I'll write down probability. Probability for sum greater than equal to 6. See here. Okay, toss 1. Getting any value on toss 1, probability 1 by 6. Okay. What do you want on toss 2? 5 or 6. Any 2 outcomes out of 6, 2 by 6. Then second case, toss 1. Getting a 2, 1 by 6. Getting 4, 5, 6. Getting any 3 outcomes out of 6. Next case, 1 by 6. Okay, then toss 2. Any 4 outcomes out of 6. Next case, there is no probability. Next case, there is no probability because the sum is not at all equal to 6 or greater than 6. Last case. Okay, what is the probability of getting 6 on the toss 1? Again 1 by 6. Okay, again 1 by 6. What about second one? Second, there is no second toss. So that is why I don't write its probability. There is no second toss, nothing to be written. But still it is our favorable case because as I told you, if the toss 1 itself is 6, even though the toss 2 is not there, but the sum satisfies greater than equal to 6. The sum satisfies greater than equal to 6. Now, what is that combined probability? Okay, so in the first case, it is 36. In the next 4 by 36 and next 1 by 6. Even this 1 by 6, let me write it on the denominator 36. So this is 2 plus 3 plus 4 plus 6. 2 plus 3 plus 4 plus 6. And hence the answer is 15 by 36 or giving you the answer as 5 by 12. Good question. Okay, 5 by 12. This one is a good question, dear. The answer is 5 by 12. The final answer 5 by 12. Okay. Yes, Sharma Shavli, I am doing good. How are you? Okay. Chalo, let's get moving ahead. Let's get moving ahead towards the next question. Okay. 4 fair. Okay. 4 fair 6-sided dice are rolled. Find the probability that sum of the results is 22. Okay, now it is about 4 dice. Now it is about 4 dice. Okay, are rolled. What is the probability? Normally the questions on 4 dice will be lengthy. Normally the question on 4 dice will be lengthy. Okay. But will it be lengthy here? Let's try to understand the pattern. Okay, so normally, the 4 dice will be lengthy. Okay, now what is the total possible values of the sum? When there are 4 dice, the minimum sum is 1, 1, 1, 1. Okay, minimum 1, 1, 1, 1 on every dice. So minimum sum is 4, then it would be 5, 6, etc. The maximum value of the sum 6, 6, 6, 6 to 24. So this is the range of the sum. There can be any sum between 4 to 24. Okay, and normally I repeat, the question on sum on 4 dice will be normally lengthy. But if the value of the sum in the question is towards higher side or towards lower side, towards lower side means if the sum is like 4, 5, 6, or higher side is like when the sum is 24, 23, 22, if that is the question, it will not be that lengthy. Okay, it is achievable. Okay, so out of this, I want the sum equal to 22. Okay, now in how many ways I can get the sum equal to 22? Okay, suppose I don't get a 6. Will I be able to get sum equal to 22 if there is no 6? See, case by case. Okay, first possibility, okay, if there is no 6. Let us think with respect to 6's. Why I am thinking with respect to 6's? Why I am thinking with respect to 6's? Because sum is on the higher side. Okay, so higher side you can go when you get more 6's. So suppose, if there is no 6, okay, then can you get sum equal to 22? No. Then the maximum possible sum is 25. So this case is not required. Okay, if you get a single 6, okay, then also the maximum sum, single 6, rest all maximum 5 and 6, 21. Okay, so this is also not required. Okay, this is also not required. Okay, case number 3. Okay, case number 3. Okay, if not 1, okay, if I get 2 6's, then can I get? Yes, because 2 6's, okay, 6 plus 6. If you get 2 6's, you have 6 plus 6 plus something. This should be 22. Okay, so here you have to get a sum of 10. Okay, here you have to get a sum of 10. And sum of 10 can be obtained as 5. Can be obtained as 6 4, but I don't take 6 4 here because that will become 3 6's. That we will see separately. Okay, I'm talking about 2 6's, only 2 6's. Okay, only 2 6's. So what is the possibility? 6655. 6655. Okay, but is it necessary that 6655 is in this pattern only? Okay, maybe 6556. Okay, these 2 6's, I need 2 6's. It can be anywhere in the beginning or end, or maybe first and fourth position, second and fourth position. It can be anywhere. So in how many ways you can select any 2 positions for 6 out of 4? Okay, total cases here is equal to number of ways of what? Number of ways of selecting 2 positions. 2 positions for the 6 out of how many positions? Out of 4. Okay, selecting 2 out of 4 is 4C2, and 4C2 is given by 4 into 3 divided by 2. This is 6. There will be total 6 cases. Okay, there will be total 6 cases. No, audio is there. Shruti, audio is there.
For the 6. Out of how many positions?
Yeah, I'm able to hear it. The audio is there. Okay. Then the last case. Okay. The next case. When you think about 4 6's. Sorry, not the 4. I have done 2 6's. The next is 3 6's. Next is 3 6's. Okay. Next, let us take that is a 3 6's. So if you have 3 6's, 6 6 6 and question mark, total sum is 22. So of course this question mark is 4. Okay, so the case is 6664. Okay, how many total cases? Again, let me not write down the entire theory. Okay, here these 3 6's can be anywhere out of the 4 positions. Okay, so the total cases should be 4C3, selecting any 3 positions for 6 out of 4. So 4C3. 4C3 is also equal to 4C1, and this is equal to 4. NC1 is equal to N always. Correct, dear? Okay, so this is 4 cases. Acha. Now, if you think about next, all 4 6's, then straight your sum is 24, which is not required. I don't require sum of 20, I don't require sum of 21. I want sum of 22. So only case 3 and case 4 are becoming our favorable case. Now what is the probability? Okay, probability is as always favorable by total. How many favorable cases? 6 here and 4 in the next one. Okay, divided by total. Now, okay, with respect to 4 dice, as I told you, if it is n dice, what is the sample space size? 6 power n. So it is 6 power 4. So 10 is divided by 1296. Or if I cancel by 2, it should be 5. Okay, and then divided by 600 and how much? 48. That is the last answer. Hope you have understood. Okay, this is a good question again. 10 by 1296. It's more about, dealing with counting based on dice. It's ultimately counting only, but based on dice. Last class also we were discussing some counting questions, but they were mostly like ball, bag, etc. Okay, this is especially with respect to dice. This is especially with respect to what? With respect to the dice. Alright. Okay, let's move ahead to the next question then. Okay, and let us go on towards some of the counting based on the cards. A card selected at random from a well shuffled pack of 52 cards. What is the probability that it is a spade or a face card, It is a king or a red card. It is a king or a queen card. Yes. What is the probability that it is a spade or a face card, king or a red card, okay, or king or a queen card? Okay, now, again, question based on cards are also important and expected for you. So that is why before we take up any such question, let me quickly make you recap what are all the things you need to know about cards. If you have played the game of cards, you must be knowing it. You know what is there in the pack of 52 cards. What is there in the pack of the 52 cards? Okay, so have a look into it. In the pack of 52 cards, we have total 4 suites. Okay, we have total 4 suites and each suite containing 13 cards. That is how 4 into 13 is 52. Okay, now what are the 4 suites? Okay, 2 of them are actually black. Okay, this has been printed white. No, this is black. This is black. Okay, this is black and this is black. Okay, so these are spades and clubs. Okay, these are the spades and clubs. Okay, and they are black in color. Hearts and diamonds, these are red in color. So how many red cards? 26 red cards and 26 black cards. So as per color also we can say 52 cards are divided into 26 black and 26 reds. Out of these 4 suits must be known to you. The spades and the clubs, these are black. The hearts and the diamonds, these are red in color. Okay, so that is what is also mentioned here. Now every card, as I told you, has 13. Every suit has a 13 cards. What are the 13 cards? Okay, ace, king, queen, jack, and then 10, 9, 8, 7, 6, 5, 4, 3 and 2. Okay, out of which this king, queen, jack, okay, they are known as face cards. King, queen, jack, they are known as face cards. You know, face card simply means, the card which has some face printed on them. So if you have seen those cards, you must have noted, okay, the face printed over them, the jack, the queen and the king. Okay, okay. So overall in every suit you have 3 face cards, so total 12 face cards. Total 12 face cards. Okay, in every suite 3. Okay, there are 4 suites. The 4 3s are 12. Okay, so this is what you should, if you have played the game of cards, you will be knowing it. If not, you should remember it. Anyways, I'll share you this PDF, so these notes will be there for you. Okay, so now let us come to the question. A card is selected at random from a well shuffled pack of 52 cards. What is the probability that it is a spade or a face card? Let's do it here. First one. Okay, it is a spade or a face card. So dear, spade. How many spades? Spade is a suite. Okay, so there are 13 cards. Okay, there are 13 in number. Or a face card. So how many face cards are there? Just now I told you there are total 12 face cards. Okay, so what is my answer? Is it total favorable cases upon total number of cards? Favorable cases 13 plus 12 upon 52. No, if you write it this way, it is wrong. Okay, I'll share you the PDF password also. Just wait for it. Okay. So, is it 13 plus 12? No. The counting here is inappropriate because you told that there are 13 spades and 12 face cards. Do they have anything in common? Okay, there are 13 spades, there are 12 face cards. What are face cards? Face cards are king, jack, queen, and they are in every suite. So there will be 3 face cards in spades also. There will be 3 face cards in spades also. That means those 3 face cards are counted double. Here also I have counted, here also I have counted. So that is wrong counting. So that is what, whenever there is common element, we subtract. Okay, so how many face cards which are of spades? Yeah, let me write it this way. Is there anything common? Yes, and these are the 3 face cards which are of spades. 3 face cards of spades. They are common to both. Okay, they are common to both, and hence my answer should be 13 plus 12 minus 3, because these 3 face cards are counted double. Okay, so I am subtracting them once upon 52. It is just same as the formula that we know, PA plus PB minus PA intersection B. Whenever is the intersection, whatever is the common, we subtract it. Okay, so this becomes 22 by 52 is the correct answer, or I can say 11 by 26. Or I can say the 11 by 26. Second one. Okay. What is the second one? A king or a red card? Okay. That is a king or a red card. So how many kings are here? Okay. How many kings are here? Okay. So there are total 4 kings. And how many red cards are there in general? Okay. Total 26 red cards. Okay. Again, is there anything common? Yes, dear. So red cards are built out of 2 categories. Hearts and diamonds. Red cards are built out of 2 categories, hearts and diamonds, and every category has a king. Every suite has a king. So there is a king of hearts, there is a king of diamonds. There are 2 red kings. Okay, so those 2 red kings are counted here also and here also. Okay, so there are total 2 red kings which are counted twice, so I have to count it only one, and hence the probability will be 4 plus 26 minus 2 divided by 52. Favorable upon total. Favorable upon total. So this time it is 28 by 52, cancelling by 4, 7 by 13. 7 by 13. Okay. Yes, I do provide the PDF. I provided for the last class also, Kaushik. Okay. Chalo. Next. Number 3. Okay. Number 3rd question. A king or a queen card. Okay. Number 3rd. A queen or a queen. Let me solve it here only. So how many kings you have? 4. Similarly, how many queens you have? Or also 4. How many of them common? So king and queen, are they common? They are 2 different cards. There are 4 queens in each and every suite. There are 4 queens again, 1 each in every suite. Okay, but there is no card which is king and queen both. So there isn't anything common here. There is no card which is king and queen both. Okay, and that is why here you can directly add. Your answer is 4 plus 4 by 52. Okay, that is 8 by 52, or cancelling by 4. It is 2 divided by 13. It is 2 divided by 13. It is 2 divided by 13. That is the 3rd answer. Here there is nothing in common. If there is nothing in common, then okay, no need to subtract.
There is no card which is...
Okay. Chalo. So question based on cards. Acha. Because we are, discussing about cards, kings, queen, and etc. Let me give you the PDF password. Okay, let me give you the PDF password. Of course, we have some more questions for the session. But as I keep telling you, whenever I present a question, your focus should be solving the question on your own. Okay, but at the same time, whatever is a detailed solution or some background required or some theory like this required, okay, everything is there in the PDF, and I will share the PDF in Telegram. But all those PDFs are password protected, because those who watch the class, they see the password and they only need the notes. Okay. Those who are watching, those who are following, they need the notes. Not anybody else, okay, should not get the notes. That is why I keep it password protection. And the password is King, K-I-N-G. Okay, small, everything in small, K-I-N-G. Everything is going to be in small, okay? Let's move ahead to the next question now. Okay, one more question based on cards only. All kings, jacks, diamonds have been removed. All kings and jacks and diamonds have been removed. Okay, from a pack of 52 playing cards, and the remaining cards are well shuffled. Okay, so what all are removed? See, how many diamonds are there? Diamond is again a suite, so there are 13 diamonds. And how many kings are there? Okay, there are total 4 kings. Okay, and how many jacks are there? Okay, there are 4 jacks. Okay, so anything common here? Again, anything common here? There is 1 king and 1 jack in diamonds also. That is counted twice. Okay, that is counted twice. Okay, 1 king and 1 jack of diamond. Okay, so actually I should write 3 king and 3 jacks, because 1 is already counted in diamond, 1 each. So that is why common 2 I will subtract. Okay, so 13 plus 4 minus 2. This becomes 19. Correct? 19 cards are removed. What they are first telling, these cards have been removed. So if 19 are removed, how many are left? 52 minus 19, 33 cards are left. 33 cards are left. Okay. Now let's understand the problem next. Okay. A card is drawn from the remaining pack. Okay. Find the probability that the card drawn is a red, is a face, is a black, is a heart. Four questions are here. Okay. Now out of these 33 left cards, left cards, see, 33 cards are left. Okay, out of which diamonds are gone. Okay, hearts are still there. How many hearts are there? Okay, 13. No, but all kings are also gone. So 13 minus 1, king and jack. Okay, this is for king, this is for jack. Okay, so how many? 11. Hearts are 11. Okay, then we have spades and clubs. Okay, now diamonds are 0. Okay, spades. How many spades are there? How many spades are there? Actually 13, but out of which king and jack removed, so 11. Okay, and then clubs. Okay, clubs are also 13, king and jack removed, so these are 11. That is how 11 is 33. That is how 11, 11, 11 is 33. Okay, that is also justified. Out of which, okay, 0 plus 11. So I have 11 red. Okay, and 11 plus 11, 22 black left. Okay, so what is the first question? What is the probability of getting a red queen? Okay, a red queen. Okay, so see, all diamonds are gone, hearts are there. Okay, king and jack gone. Okay, so what is the first answer? Okay, what is the first answer? Red queen. Okay, do you have a red queen left? Yes. Okay, so what is the probability? 1 upon total, favorable by total, 1 upon 33. Okay. Then a face card. How many face cards are still there? See, how many face cards are still there? Okay. In every suit there are 3 face cards. Okay, king, jack, queen, but king and jack are gone. Only queen is left, and that too diamonds, everything is gone. So there are only 3 queens. Okay, these are all queens. Okay, these are all queens. These are all queens. Okay, so what is the probability of getting a face card? Favorable upon total. Okay, 3 by 33, 1 by 11. Question number 3. Okay, black card. Okay, so how many blacks are here? As I already told you, how many black cards are available? How many black cards are available? So we have total 22 black. So probability of drawing a black card, okay, is favorable upon total. 22 by 33, 2 by 3. Okay, and 4. What is the probability of getting a heart? So how many hearts are there? Already discussed, 11. Okay, so probability of drawing a heart is 11 by 33. Or that is 1 by 3. Or that is known as the 1 by 3. Right, everybody?
2 by 33, 2 by 3.
That is 1 by 3. That is the final correct answer. Okay, dear. That is what is the final correct answer. Okay. Chalo. Let's move ahead to the next. Okay, so this is again a good question based on cards. Some of the cards have been removed. Okay. No, for fundamental probability, it is good. Okay, then for probability distributions, we need to plan some more sessions. Okay, but basic probability, conditional probability, Bayes theorem, Dinesh, all that I am covering here. Okay, then next step of probability is distribution, random variable. Okay, like binomial distribution, Poisson distribution, normal distribution. Okay, all that also I will try to take in YouTube, but not immediately, sometime later. But right now, all fundamentals of probability like Venn diagram based, counting based question, cards based question, or conditional probability based theorem, that is what you're going to get in these days. Okay, next session will be on conditional probability. Will comprise the questions on conditional probability. Okay, next question. 2 points are selected at random in the interval 0 less than x less than 1 and 0 less than y less than 1. Determine the probability that sum of their squares is less than 1. Determine the probability that the sum of the squares is less than 1. Sum of the squares is less than 1. 2 points are selected randomly in the interval 0 less than x less than 1, 0 less than y less than 1. Okay, now here it is about selection of 2 points anywhere in the interval. Okay, so see, just have a look into it. Okay, from where I can select the 2 points. Okay, so because it is 2 points x and y, let me draw 2 axes here, and that comprises a 2-dimensional plane. Suppose this is x axis, y axis. All values of x minus infinity to infinity, all values of y minus infinity to infinity. But the 2 points which are to be selected are at random in the interval 0 less than x less than 1, 0 less than y less than 1. What is the probability that sum of the squares, okay, is less than 1? Okay, sum of the squares is less than 1. Okay, you want x square plus y square, sum of the squares should be less than 1. Okay, so now the points x and y are selected only in the interval 0 to 1, 0 to 1. That means x can be selected here. X can be selected, okay, somewhere between 0 to 1. Okay. Similarly, y also can be selected anywhere between 0 to 1. This is how it looks like. Okay, x can be anywhere between 0 to 1. Okay, if you choose any value of x between 0 and 1, y also can be anywhere between 0 and 1. Okay, and this makes a square space, square or a rectangular space. Okay, square or a rectangular space. Okay, like this can be in point coordinate, point theory 1 comma 0. This is origin 0 comma 0. This is y-axis 0 comma 1 and this is 1 comma 1. Okay, so whatever point is to be selected, okay, it is between this. So I can call this as my sample space. Okay, sample space, list of all possibilities. Whatever the value of x or y you select is within this. Okay, and set of all possible outcomes is what is known as the sample space. But how many points are there in the sample space? How many values of x are there between 0 to 1? If you count all possible real values, 0, 0.1, maybe 0.111, 0.111111111. Okay, or after 0 you can even consider 0.0000001. This is also a real value. So if you want to count total number of real values between any two numbers, it is always infinite. So how many total points are between, how many total points are available here? Total infinite number of points are available here. Infinite number of points are available here. Okay, out of those infinite points, okay, we need to select those points such that sum of the squares is less than 1. Acha, less than 1, na? Okay, suppose x square plus y square equal to 1. Then what is the figure you draw? X square plus y square equal to 1 is a circle, na? X square plus y square equal to 1, if I tell you, that will be taken as a circle. Okay, that will be just taken as a circle having the radius 1. Okay, so that is actually a circle. See, that is actually a circle of this kind. Okay, but you know na, we cannot select anything outside the universe. We cannot select anything outside the sample space. My sample space is this rectangular box, so I cannot go beyond this. So that is why the part of the circle which is within this sample space. Okay, this portion. Okay, so actually this is x square plus y square equal to 1. But what I want x square plus y square less than 1. Okay, any point lying on this circle will have radius 1. So if you want less than 1, you have to come inside this. Okay, so this is what is the portion. This is what is the portion that will be x square plus y square less than 1. X square plus y square less than 1. Now again, how many points in this space also? Infinite points. So whenever you get a 2D picture, you can use geometry here. Okay, because it is not countable set. You cannot count the total number of sets, total number of points in the sample space. Total number of points here also will be infinite. If I keep on counting each and every point like 0, 0.00001, like this, if I count each and every point, infinite. Okay, but the set of all points make a 2D space. And whenever you get a 2D space, write down the probability as favorable. Number of outcomes you cannot say because number of outcomes are infinite. So write it as favorable area upon total area. Okay, favorable area upon total area. Okay, so you get two-dimensional spaces. Okay, you get two-dimensional spaces, and in that case we can calculate the probability again by the same idea, favorable by total, but it has to be favorable area for 2D space divided by the total area. Total area means the area of the sample space. Okay, total area here would mean the area of the sample space. Okay, so let us see what is the answer here. Okay, what is the favorable area? Okay, favorable area is area within this circle, and area of a circle is pi r square, but this is only quarter of a circle. 1 by 4 pi r square divided by total possible area is the area of the square, and the area of a square is given by a square. Okay, now let us put down the value. Radius of the circle is 1 and the side of the square is also 1. Okay, and hence the final answer that is left is pi by 4. This is solved by geometry. The final answer left is pi by 4.
1 by 4 pi r square.
Some sound issue just again. Let me correct that once again, dear. Just checking it again. I think okay now. Okay dear. So let's continue. Okay. So in case when you get the total number of elements which is uncountable, that they make a 2D space, so we can calculate the area of those spaces, favorable area upon total area. Next question. A cow is tied with a pole of 100-meter long rope. A cow is tied with a pole of 100-meter long rope. What is the probability that at some point of time the cow is at least 60 meter away from the pole? 60 meter away from the pole. Okay, so see dear, once again, let us say this is the pole. Okay, and then there is a cow. Okay, which is, okay, a cow is tied with a pole of 100-meter long rope. Okay, so it is tied with a particular rope. Okay, say this is rope and which is total 100 meter in length. Okay, but of course without breaking the rope the cow is free to move. Okay, so in what are the ways the cow can move? Okay, cow can move, so the cow can move only around this pole. The cow can only move around this particular pole, and hence it is able to move in a circular field, and hence it will be able to move in what? Hence it will be able to move in a circular field.
Okay.
Correct? Having a radius of 100. Having a radius of 100. Now what you want is, so this is what is my sample space now. This becomes my sample space. The cow will be able to move in a circular field, okay, of 100-meter radius. Okay, anywhere within this also, the cow can come inside also. Okay, it only thing is the length of the rope is 100 meters, so it cannot go beyond 100 meter, but cow can be here also, here also, here also, here also, here also, anywhere. Okay, take the circular field of 100-meter radius. Any point within this circle is a sample space. Correct? Is my sample space. What I want, at some point of time the cow is at least 60 meter away from the pole. Okay, at some point of time. So now let me draw the proper picture explaining this situation. Okay, so suppose this is the sample space. Okay, now let me take another circle whose center is same, a radius 60. Okay, so here this is the pole. This is the pole, and now, okay, let's say this is 60 meter radius and say this is 100-meter radius. The maximum distance cow can move is 60 meter. But what is the probability that at some point of time you find the cow which is 60 meter away from the pole? 60 meter away from the pole. This is the pole and the cow is at least 60 meter away. So where is the cow? Where is the cow? Here is the cow. Okay, this is what becomes, this is what now becomes your favorable space. Okay, and hence again, because the favorable and total portions represent a 2D space, okay, like circular spaces, so you can calculate the probability in terms of area.
Where is the cow?
You can calculate the probability in terms of area, and hence what is the answer to the probability? Probability, once again writing it as favorable area divided by total area. Favorable area by total area. Now what is the favorable area? Is area within these two circles. Okay, so that is equal to pi into 100 square. Area of circle is pi r square. Okay, so area of outer circle minus area of inner circle. You want the area between the two circles, the outer circle area minus inner circle area, divided by sample space, and sample space is this complete outer circle. Okay, this circle of radius 100 meter. Okay, so what is the total area? That is pi into 100 square. That is pi into 100 square. That is what should be the answer. So of course clearly pi is cancelled. Okay, 100 square that is 10,000 minus 60 square 3600. Okay, divided by 10,000, or it is equal to 6400 by 10,000, or 0.64 is the answer. Okay, 0.64 you can check out. Yes, greater than, the cow is at least 60 meter away. Correct. Okay, so that is what your answer is. Okay, 0.64 is your final answer. Hope that is clear to you. Okay, so some questions that can be, related with geometry. That is what some miscellaneous questions also I wanted to cover. Okay. All right, towards the end, let me also, remind you that the GENCO test series, okay, has been announced by OM Institute, and that is free online test series for all aspirants or EE aspirants of GENCO. There are 2 full mock tests, one on 23rd June, that is the coming Sunday, and then next on 7th July. Okay, just you have to, you can scan this QR code, open the QR scanner of your mobile, and you can go for the free registration. All the tests will be active at 1 p.m. Okay guys, the next offline regular GATE batch, okay, the offline regular batch, okay, at Hyderabad live in front of faculty, one-on-one interaction, one-on-one best guidance you can get at these offline batches. Okay, ECEE, both the batches start from 26th of June, okay, 26th of June, that is just next week. Okay, the fee 66,000 has been currently priced at 56,000, and also there are 50% scholarship for IIT and IT students, 50% for OM aspirants, and 30% for triple ITs and state government university students. Okay, in case by chance you cannot travel to Hyderabad and you're looking to prepare online, so yes, there is also the online live batch. Study and sit at your comfort from any part of the country, but by the guidance of the same expert faculty team. Okay, we have the same faculty team for offline and online, so you get the best content and best faculty team for both the batches. So online live batch, okay, the fee is 29,999, but currently priced at 19,999 for 12 months and 28,999 for 12 months validity in case if you're preparing for GATE 2026. These live classes you can access from our app as well as our website, OM Institute, www.ominstitute.live, or even our OM Live app. Okay, for any queries regarding to these batches, okay, you can contact 95156944043. Okay, 95156944043, or visit our website www.ominstitute.com. Okay, that's it from my side, and as I told you, I'll share you the PDF in my Telegram group. Okay, so I'll do share it. Okay, be connected with me in the Telegram. Okay, so guys, that's it. Tomorrow there is a GENCO session. So for those who are preparing for GENCO Control System Part 2, so yesterday, actually students right now are more looking for GENCO sessions rather than GATE, I feel, based on the attendance, because yesterday GENCO class, a lot of attendance was there. So tomorrow there is a Control System Important Question Part 2. Because it is the end, just last 1 month left for the GENCO exam. So last 1 month mostly more about practice and revision. So we are bringing you both practice as well as later on revision modules. Okay, so control system complete practice session part number 2 tomorrow at 6 p.m. That is for GENCO. And next class on probability will be part 3 based on conditional probability concept. Okay, with this I'll sign off. Bye bye. Thank you. Good night. Stay safe and do take care of yourself.